So we're going to go ahead and draw our unit circle and just the compass point ones, all right? So what is our coordinate right here at the beginning of the circle when you haven't rotated anywhere? Yep, 1, 0, perfect. Up at the top, 0, 1. Side is -1, 0. Oops. And then 0, comma, -1. Dyslexic moment for me there. I might rewrite that because I'm going to have to show this to everybody. So let me just redo that real quick. Whoopsie. I'm modeling for you what you do if you make a mistake, which is to not get upset and just do it again, okay? Also write with pencil, and then that won't happen. Here, let me switch to a pencil. There, see, I'm modeling all kinds of good behaviors here. So you can use this, so you don't have to write this over and over again on every single piece of paper. You can just bring your sticky note to the next side with you. Get what I'm saying? And I'll let you use it on the test too. Just, I feel like you know this at this point, so I'm fine with you using it on the test. Now, if you write all kinds of other stuff on your sticky note, I'm not going to be able to let you do that. So sine, is that the y value, the x value, y over x? That is the y value. So we're going to go around our circle and grab all of our y values, okay? So sine of 0 pi, that's right here. What's your y value? 0, good job. Pi over 2, that's up here at the top. The y value is 1, good job. At pi, 0. At 3 pi over 2, your y value, -1. And back where you started, 0. Hopefully you notice a little bit of a pattern there. Now we're going to go around the circle backwards. Okay, so let me migrate this down here. Negative pi over 2, went backwards pi over 2, that's going to be -1. Negative pi is actually the same as positive pi, so 0. If you go backwards 3 pi over 2, that takes you up here to the top, so that is 1. And then -2 pi is the same as positive 2 pi. You should feel like you're speaking in binary, you know, like all the ones and zeros, you know, like computer language, or what? Does anybody do programming? Do you know what I'm talking about? Like all the zeros and ones. All right, so now we're going to plot those points on a graph. You're going to have to look at your paper because I don't want to go like this and make you seasick. I'll do it for like the first point, but then you're going to have to just pay attention, all right? See how we start at 0 pi 0? That is the origin. And you'll notice I have the x-axis scaled by pi over 2 for you. I set it up so that you're ready to go. Now, I'm not going to shift the paper up and down. Look on your paper. What is your point for pi over 2? 1. It's 1. And then you're back to 0. And then down to -1. And then back to 0. And then we went around the circle backwards. But my hope is that at a certain point, like your pattern instinct will kick in and you will go, oh, I can just continue this. Now, when you connect those, a couple of things. I'm not here to grade your art skills, but you need to attempt to make it a nice, smooth curve. I don't want to see anything that looks like a jack-o'-lantern mouth with like a jagged edge. Do you get what I'm saying? Make an attempt. And other thing is, you don't want to put arrows on the ends. What does an arrow indicate? That it continues that direction forever. Here, watch, I'll do it wrong. Okay, don't do this. If I put an arrow here, that means that's going to go down forever. Is that what it's going to do? No, it's going to continue waving forever. So I will take off if you stick arrows on the ends because that means something that's not true. Okay, so make an attempt to make it a nice smooth curve. And just don't stick arrows on the ends. Cool so far? It's a pretty graph, isn't it? I like the fine graph. Okay, so a couple of things I want you to notice. Domain. It's going to go left forever. It's going to keep on waving. And it's going to go right forever. So your domain is all reals. Everything. That's the answer. On the test, that's the answer. Okay, I can't change it. Range. Sweep downwards to upwards. It's been a while since we've done this. We've been doing trig for so long. It's been a while since we've looked at some graphs. So you are stuck between what and what? Downwards to upwards. -1 and 1. There are actual points there. So brackets. They aren't asymptotes. So you want to include those points. This graph is continuous. I bring that up because not all of the trig graphs are continuous. Do you remember on your last test how sometimes the answer would be undefined? What does that mean is going to be in the graph? I'm just foreshadowing for like next time. It will be discontinuous due to asymptote. Thank you. Okay, we all went like this. All right, do you remember even and odd? I'm sorry, I'm not done. Do you remember even and odd? This is an odd function. Again, I'm bringing that up because it's not going to matter so much this unit, but another unit we're going to do, you need to know which ones are even and which ones are odd. So I'm bringing it up now. Odd means it reflects across the origin. Do you see how this part up here reflects to this part down here? Odd origin. It was like back in November that we did that, but is it ringing any bell? Like, I mean, yeah, sine is odd. Okay. So it's symmetric to the origin. I'm sorry, go ahead. Yes. So like if you took all of this and reflected it over here, like it goes through the origin. Don't overthink it. I usually just look at the first little bit of it. This part reflects down here. Okay. So odd. Let's do our y-intercept. I'm not doing x-intercepts because there's an infinite number of them. There's no way to write them all. But what's your y-intercept? Yep, 0, 0. And then new piece of vocabulary, period. That is the amount of space it takes to get back where you started. And so I'm going to use another color. Just watch me do this. You start here at 0, 0. Graph goes up, comes back to that center line, goes down and comes back to that center line. Do you see how that's one full cycle of the wave? All right, so how far is it to do one period of the function? 2 pi. Which should make sense because 2 pi is what? A full rotation. Good job. Perfect. That went really well. So here's what I'm going to do. I'm going to shut my mouth and I want you guys to try and replicate what we just did on this side. It's the exact same thing except cosine, and literally the only difference is when you go around this circle, instead of the y values, how do you get cosine? They're the x values. I'm going to set this aside, pause the recording. I'm going to fill it out too. I want to hear you talking with your group, and then we'll just make sure we all got the same thing. So again, don't put arrows on the ends. It's going to continue waving. It won't go one direction forever. Domain is all real. It's going to go left and right. Your range, you're still caught in between -1 and +1. We want the brackets. This is continuous. I bring that up though because they all aren't continuous. We will get some trig functions that have asymptotes in them. And then let's talk about this. Even is symmetric to the y-axis. So look, do you see how this part reflects over here? Yeah. Like over the y-axis, okay? So even function, again, I'm bringing that up now so that later on when I'm like, hey, do you remember how this one was odd and this one was even? Hopefully you'll be like, yeah, Miss Cole, we remember that because you explained it to us, all right? Now this is what I really want you to understand, the difference between sine and cosine. Sine starts at the origin, cosine starts at 1. So if you remember where they start, you can get the rest of it because they're both just a wave. And again, I kind of highlighted it here. The colors don't show up real great, but do you see how one cycle, one period of the function to get you back where you started is 2 pi? And again, that should make sense because 2 pi is like a full rotation of the circle. So what we're going to do with this overview right here applies to all of the trig functions. What I'm going to write out is going to involve like almost every letter of the alphabet, and you're going to go, wait, what on earth is going on? And then I'm going to explain what it all means, and we're all going to calm down. It's just like everything that we do. All right, so function, we're going to have f of x equals a. And then what would come after the a would be either sine, cosine, tangent, cosecant, secant, cotangent. But it's any of the 6. So to write it just sort of in general, I'm just going to write trig. Do you get what I'm saying, though? It could be any one of them. I'm writing the like in general version of this. All right, bracket, b parenthesis, x minus c, and then plus d. So you have an a, b, c, and d. Please don't talk over me. I'm going to have to say the same thing to you that I say to my freshmen, which is if you're talking, you're not listening. So we're going to talk about what the a, b, c, and d all mean. All right. Basically, we're going to give new vocabulary to stuff that you already know. You already know all of this. We're just going to give it some new vocabulary. Amplitude is your a value, but it must be positive. And amplitude is a distance, so it cannot be negative. So when you're doing the wave, it's the distance from the center line. Have any of you taken physics and you've done sound waves and things like you probably heard the word amplitude? It's the distance from that center line. So a distance cannot be negative. Also, it's only for a wave. So this is only for sine and cosine. All the others, they're not waves. I realize I haven't taught them to you yet, but they're not waves. They're other shapes. Amplitude is only for a wave. So the other ones, you'll just say none. There just won't be one. Okay. Now, what you have called this before is your vertical stretch or shrink. That's what it is. It's your vertical stretch or shrink. You've done it before. We're just giving it a new name. It's just a new piece of vocabulary. But you remember vertical stretch by 3, vertical shrink by 1/2? It's that. All right, period. Once around the circle is 2 pi, you're going to divide that by your b value. But again, it can't be negative. So you're just going to absolute value it. This is your horizontal stretch or shrink. So think like an accordion. Use your imagination. Can you imagine taking the wave and stretching it like this or shrinking it like this? Like an accordion? All right, it's your horizontal stretch or shrink. Phase shift is this C value, and that is your left or right. Do you remember like left 3, right 7? And it's kind of backwards. Remember, those are opposite. Left, right. Phase shift, we're calling it phase shift. It has a new piece of vocabulary, but it's the same thing as before. And then D is your vertical translation, which is just your up or down. And that makes sense. If you do +3 at the end, the graph moved up 3. So these are just all your transformations. Now range, I'm going to write it up here, but what you can do is just wait until you're done and then look at it, like just look at the graph. But if you're like, hey, I want a way to figure that out, off to the side here, draw yourself a little dotted line. That's going to be at your D value. So if you moved like up 3, like I said, that center line is now going to be at 3. Instead of on the axis, it's going to be wherever you moved it. Still with me? Like up or down. So here's your wave. And this distance is A. That's your amplitude. So your distance from that center line is that A amount. So how could you get this low value? The center is D, and you are A units below it. Close. You made it. Oh, no, there's not going to be any dividing. What's your center line? D minus A. Do you see how you guys are overcomplicating that? Like now you're just throwing things out. You're not even using your brains at all. Can you look here? Do you see how the center line is D? Yeah. To get down here, you would subtract A. No, you said A minus D. And I said you're really close. And then you went the opposite direction and started making it worse. All right. So it's going to be D minus A. That's that low value, comma. And then how could you get this maximum value? D plus A. But again, if you don't like that, which it seems like none of you really did, just wait until you do the graph and then look at it and go, oh, that's what it is. Okay. So here we go. We're going to try one of these. What is your domain? I told you this is the answer. Yep. All reals. It's a wave. It goes left and right forever. That's the answer. We'll hold off on range because that seemed a little sticky for you guys. So we'll just wait until we get the picture. Amplitude. What do you think? Based on what I just explained to you and looking at these numbers here. 3. It would be absolute value of 3. Just 3. All right, period. You put 2 pi over the B value. That's whatever is in front of the X. It's whatever's in front of the X. Do you see that there? Okay. What's in front of this X? 1. Which means it's just 2 pi. It means there was not a horizontal stretch or shrink. It didn't change. I'm trying to give you an easy problem to start with, so I didn't stretch or shrink it that way, okay? Phase shift, that's your left or right. Do you see anything in here with the X? Yeah, is there anything there? No, so there isn't one. You can say 0 or you can say none. I usually just say 0. It didn't move. You could even put pi with that. No pi. All right. And then what's your vertical translation? Yeah. And you can write down DOWN 4, or you can just put -4. They both mean the same thing. So that's up to you. All right. Now, when you go to make your table of values, you are going to start with your phase shift. Whatever your phase shift is going to go in that first box. That's your movement left to right. You're shifting to wherever your new center is. You're coming with me on this? Like you're shifting to wherever the new center is. Now this one, I made it 0, and you can even put 0 pi, all right? No pi. Because I was trying to start with an easier one for you. And then what you're going to do is add the period. Because you want to go one full cycle. So you take where you shifted to, and you add the period. So what was the period for this one? Again, I didn't change it because I wanted to start with kind of a softball problem. So 2 pi goes here. Now I'm going to stand up to do a pep talk. This is where you have to understand fractions. Okay? You're going to be all right. What is halfway between 0 and 2? 1 pi. Okay, so pi goes in the middle. What is halfway between 0 pi and 1 pi? Pi over 2. Good job. And then what's going to go here? Do you notice that those are the unit circle values? Again, I was trying to start out with an easy one. But here's the good news. If you struggle with that, make something up. You can still get the other half of the table because of the way I teach this. It's so that if you can't get that, you can still get the rest of the problem. Take another color if you've got it. If not, it doesn't really matter. But we're going to box in our trig function. And you got that sticky note? We're going to go around our circle. Are we going to pull the x values or the y values? This one's sine. Y values. And look it. You're going to multiply them by 3. And then minus 4. What's your first y value? We're going to start at the beginning of our circle.
0.
0 times 3.
0.
0 minus 4. Good job. Now go to the top. And it doesn't even matter what this says. Just go around your circle. What's your y value? 1 times 3. 3 minus 4. Keep going. Still venturing around our circle. Now we're over here. 0 times 3 is 0 minus 4. You can hide from the problems if you want, but I will still give you a quiz. All right, now we're down here. Your y value is -1 times 3 is -3 minus 4, -7. The last one will always be the same as the first one. Always, Miss Cole? Yeah. If you did it right, you should end up back where you started.
Wait, are we sandwiched like that, or is that one just like, or is it just this?
They are all cyclic because they go around and around and around the circle. Okay? Yeah, go ahead. So you take the phase shift, which in this case was 0, and then you add the period to that. Our period was 2 pi. So 0 plus 2 pi was just 2 pi. I started off with one where this was 0 because I wanted to start with an easier problem. They won't all be like that, okay? Now you have to label your axis. Do you see how this counts by halves? Probably count by halves. Now I wouldn't label every single one. Do you see how I skipped every other one and just wrote pi? I don't need you to label them all. A few will do. In fact, I really don't want you to, because if you try to label every single little tick mark, it's going to get so cluttered, I'm not even going to be able to read. You won't even be able to read what you wrote. Just enough is good. Do you get what I'm saying? Now you have to do 2 full cycles. You have to do 2 periods of the function, which for these waves ends up being 9 points. So you have to show at least 9 points. So let's take what we got on our table and graph it. We're going to start at 0, -4. Actually, we have to go all the way down to -7. So can we do this? Can you like give a little tick mark halfway in between? Because we have to get all the way down to -7, and it's going to go off the grid. So you're going to start at 0, -4, and that'll be right here. And then pi over 2 is -1. And then pi is back to that center line, -4. And then you're down to -7. And then 2 pi puts you back where you start. And then I need for you to just continue that for one more cycle. Again, it should be a total of 9 points. You can go further if you want. I always get some people that want to fill the entire space. It's not necessary, though. I'm just checking that you can keep the pattern going. and it should be 2 cycles of the wave. And then if you didn't answer the range, just don't forget to go back and answer that. I try to look through these tests and catch it if you left anything blank and give it right back to you, but I can't catch everything in the world, so you're going to need to look after yourselves. So what is our range? Sweep downwards to upwards. What are you caught in between here? Yeah. Yeah, now it has to be the -7 first because it's downwards to upward. And I'll stay zoomed in for one more second there so you guys can see it, but we're gonna try it again. We should be able to get through one more before you leave. These only take a couple minutes. Okay. I know you're not anxious to get out there anyway, so.
No, I think it's still running.
Yeah.
It's not.
Or if it stopped, you can go. All right. Domain is gonna be what? This is an automatic right answer. All reals, good job. We'll hold off on the range until we get the graph. Just don't forget to go back and answer it. Amplitude, this is a little tricky for this one. What's in front here? A -1, but you have to absolute value that. So it is +1. Just remember it's a distance, so it can't be negative. Your period, it's 2 pi over b, which is whatever's in front of the x. So look at your equation. What's in front of the x? That's 1/2. Now, if you divide by a fraction, you multiply by the reciprocal. So if you divide by 1/2, you multiply by 2. So this would actually be 4 pi. So think like an accordion. Just watch me do that. Remember when I taught the transformations at the beginning and I got like a rubber band out? Do that again. Or a slinky. I used to teach it with a slinky. Pretend I have this, but I stretched it this way. That's what happened. So your wave is going to be like stretched out. All right, phase shift. That's another way of saying you're left or right. What direction did this go? Why is it positive pi? Or you could say, well, it's because your left and right is backwards. It's opposite. Now you could even say right, R-I-G-H-T, pi, or you could just say positive pi. If it went left, you can write the word left, or you can just throw a negative in there. But remember, that's opposite. All right, vertical translation. Do you see anything added out here? No, so 0 or none. I like to put 0, but you could put none. That's fine as well. Now your phase shift is what starts here. You shift to where the new center is. So our phase shift is pi, and you want to do 1 full cycle, so you're going to add the period. So 1 pi plus 4 pi is 5 pi. And now you have to figure out what's halfway in between them. What's halfway between 1 and 5? 3.
Oh,
If the pi's bother you, ignore them. Just go, what's halfway between 1 and 5? All right, halfway between 1 and 3 is 2. And then like at that point, you're just counting. Yeah. You start with the phase shift. So I just copied that over, and then you add the period. 1 pi plus 4 pi is 5 pi. But regardless of what that says, in fact, usually what I do is cover it up because it just doesn't matter. We're going to go around our circle. Are we going to pull the x values or the y values? How come y? Because you're correct. Sine, and then you're just going to do the stuff that's outside. You're going to multiply it by a negative and then add nothing. So basically, you're just going to multiply them all by a negative. Do you see that there? And then add nothing. All right. So what's your first y value? 0 times -0. Now you're up at the top. Just go around your circle. What's your y value? 1, but it's going to be -1. And then back to 0. Now you're down here, but the -1 is going to be -1. So 1 and then 0. So do you see how you can get this even if you can't get the left side of the chart? I teach it that way on purpose because this is the hardest part. So if you can't get that, I want you to be able to still finish the problem. Now you can label each of these 1 pi, 2 pi, 3 pi. I'm going to stretch it out a little bit so that I have some space. And I'll zoom in. So do you see how I did every other one? That was like a personal decision that I made just so that it didn't get so cluttered. That's kind of up to you. And now we're going to plot our points. We start at pi 0. Do you see where I'm getting that from? Right here, pi is 0. And then we go down to -1, back to 0, +1, back to 0. And I just want you to continue that for one more cycle. It should be a total of 9 points. You can go either direction. Like say you wanted to go this way. You see what I'm saying? Like it really doesn't matter. Actually, I went a little further than I needed to. It doesn't matter. As long as you do at least 2 full cycles and you can go either direction, I don't care. I'm just checking that you can continue the pattern. Again, I usually get some people that want to fill the whole space. It's not necessary, but you can if you want to. And if you didn't answer the range like from the get-go, just don't forget to go back and do that. What are we caught in between for this one? Yeah, -1 and 1. That's a good stopping point. Yes, go ahead. Okay. Make sure you didn't drop anything out. All right. Difference on this side, instead of sine, what does it say? We're going to do the exact same thing though, except when you go around your circle, you're going to pull which values? X. Only difference, we're going to just do the same thing again. Domain is all reals because it's a wave. Amplitude, what is in front of this right here? 1. Amplitude is not going to be none for sine or cosine. You have to have a number there. All right, period is 2 pi over b, which is whatever's in front of the x. So what is in front of the x? 2 pi. Do you see that right there? Now this one's a little bit weird because that turns out to just be 1. Even the pi's cancel, which is interesting. Phase shift is your left or right. So you're looking right here. What direction did it shift? It went left 1/2. So you can either write left 1/2, or I really recommend writing -1/2 because that phase shift is what you want to go right here. And you need to know that it's negative. So if you want to write left 1/2, go ahead. But you need to know when you go to your table that that's going to be negative. All right, and then vertical translation. Did we move up or down? Down 1 or just -1. So I already copied over my phase shift. We're going to add the period, which is 1. If you have -1/2 plus 1, 1/2. Good job. Now you've got to break it down to what's halfway between them. 0. Now you're going to have to break it down to halfway in between those. Yep, this is -1/4, +1/4. Good job. But if you can't get that, what did I tell you to do? Make something up because you don't need it in order to do the next part. You can still get the next part without it. We're going to get all our x values, and then we're going to subtract 1. So you're going to take all your x values and then subtract 1. You just do the stuff that's outside of that. So what's your first x value? No, we're going around our circle. 1 minus 1, 0. All right, now we're up at the top. 0 minus 1, -1. Good job. Over here, -1, minus 1, -2. Down here, -1, and then over here, 0. The last one will always be the same as the first one. Always, Miss Cole? Yeah. All right, now we're going to label our axes. You have to count by fourths. Can I show you what not to do? Please don't do this. 1/4, 1/2, 3/4. Like, do you see how it's going to get super, super cluttered? Okay. Instead, just go to the fourth one and call it 1. 1, 2, 3, 4. Call that 1. 1, 2, 3, 4. Call that 2. Then I know that all the ones in between are fourths. You don't have to label every single one of them. And then go to the left as well, because we've got some negatives on there. But do you understand what I'm saying? You don't have to do all of them. Number one, it'll be cluttered. And number two, it's a lot of unnecessary work. If you go to the fourth one and call it one, you know that these are all a fourth. Is this making any sense? Like, okay. So now we're going to label our, or plot our points. Negative a half, 0, will be right here. And then negative a fourth, negative 1, 0, negative 2. I'm not going to read them all to you because that's going to get annoying. But do one full cycle and then just keep the pattern going for one more. Again, there should be a total of 9 points, and you can always do more, but at least 9. And then don't forget to go back and answer the range if you didn't already. Okay. You're going to be upset on the test if you get -1 because you just left something blank. So don't forget to go back and do that. What's our range going to be? What are we stuck in between here? Yep. Good. And we're going to do one more. I don't need to do number 5. We're going to do number 4. So we've done 2 of each.
If you were to not do the range at first, when you were to finish the table, could you just pick out
Yeah, you could do that too. Like you could just pick out of here, okay, the minimum is -2, the maximum is 0, and do -2 to 0. Yeah. I don't care when you do it, as long as you go back and answer it, Oops. All right, we're gonna do one more. Come on, there we go. All right, plane. All reals. It's an automatic answer. Amplitude, what do you guys think? 1/2, good job. Period. It's 2 pi over whatever's in front of the x. 1, which means it's just 2 pi. So it did not get horizontally stretched or shrunk. That always makes it easier. When you have a horizontal stretch or shrink in there, that's when the problem gets wacky. If you don't have one of those, then usually it's pretty simple. All right, phase shift. It's left to right, and it's kind of backwards. So left pi over 4, or you can write that if you want. I kind of recommend writing negative pi over 4 because that's what you have to put right here. These are going to match. So you need to know that it's negative. And then what do you think for vertical translation? 0. You didn't move up or down. Oh my gosh, you said the answer already. Of course. Can I get everybody else there? All right, you're going to take this negative pi over 4 and add 2 pi. You need a common denominator. So 2 pi is how many fourths? 8 fourths. Good job. I'm just going to write myself a note. I have to take negative a fourth plus 8 fourths. 7 fourths. Good job. Now, you can ignore the fourths and you can ignore the pi. Basically, just think of a number line. What's going to be halfway between -1 and 7? And if you even want to make yourself a number line and then count them, I didn't leave enough space to do this, but do you see what I'm saying? Like if you struggle with this, you can just go -1 to 7 and then leapfrog your way to the middle. Do you see how I did that? So what's it going to be? Yeah, 3/4. Good, perfect. This will be 1/4, but good job. But you can always make a number line if that's a problem for you, okay? That's about as hard as I can make it. Now, it doesn't matter what that is though, because we're gonna just go around our circle. Are we pulling the x values or the y values? X, and then are we gonna do to them? Multiply them by a half and add nothing. So what's your first x value? 1 times a half, a half. The next one's 0 times anything is 0. How about the next one? -1/2, 0, back where you started. Now you need to label by fourths. So just go to the 4th tick mark and call that pi. And then you can go to the 8th tick mark and call that 2 pi. And here, I'll do another one. This one would be 3 pi. You don't need to label every single one, and I don't want you to. It's unnecessary work, and you're not even going to be able to read it because it's going to get so cluttered. So negative pi over 4 would be this tick mark here. We want that to be a half. Or I'll zoom in. Pi over 4 is 0. And then 3/4 is negative a half. Back to 0, positive a half. So that's one cycle. And then I need for you to just keep that going. I don't know what you're doing, but it's not what I'm asking you to do. Now you're going to know if you missed a tick mark or counted wrong or something because your graph is going to look wonky. Like you will be able to tell. I think I went a little further than I needed to, but that's okay.